certificate, that just means the certificate, there's probably something wrong with it. And we can take a look. Let me just run a Wireshark on that interface so we can actually see what the data that's going across the wire looks like. So if I go in and invoke one of these methods here, do 1 minus 1, what we should see here is that when I decode this stream, it's actually all, the message payload is actually encrypted. What's actually happening behind the scenes here. There's one to initially negotiate the key exchange. There's about a series of 4 or 6 requests for just one service call. So this is a good example of where you're going to need to use one of these tools that support, and again, you're going to be very limited. It's going to basically be either WCF Storm or the Visual Studio Test Client. Probably a handful of other ones out there. If anybody knows of any good ones, certainly let me know, because I'm always looking for more tools that will allow you to fuzz the inputs pretty easily. So the other thing you may be able to do too is if this is a client application, if you're getting certificate errors, let's say you don't have the ability to import a certificate, sometimes that can be a little tricky. If you have a configuration file on the client, you can just turn certificate validation off. So if this is an application that you're testing, a thick client, and you're having issues with it, just go to the configuration, add a specific behavior to the config file, and that'll actually disable the certificate checks. And then the other option you have is with WCF, it also supports the classic WS security username and password credentials. So if you don't have a certificate and it's not using anonymous message authentication, you're kind of out of luck. You're not going to brute force the certificate. But if it's using a username and password authentication, then you can easily brute force this. And this is one that most of the tools out there do support. So SOAP UI, for example, supports this. You just go to the WS security username option, and it's basically just a plain text username and password that gets sent in a header. So you can easily try and guess this or brute force it. The one thing to point out here is that you cannot actually do this over HTTP. WCF will not allow a web service to use this authentication mechanism unless it's going over a secured transport. So again, that's kind of a good thing that Microsoft's done to sort of prevent anybody from inadvertently exposing one of these usernames and passwords in the clear of the wire. And then the last option you can do is if your tools aren't working or if they're using some ridiculous binding, because the bindings, again, there's 10 of them by default, 10 or so by default that you can use, but then there's a custom option that lets you mix and match any of those security settings. So every now and then you may run into a scenario where the tools don't actually support the binding that you're using. And if that's the case, it's very easy to write a custom test client using WCF. It's somewhere usually on average of about 10 lines of custom code. And the reason for that is you're going to leverage, as long as you've got metadata, you can leverage the service utility that comes with Visual Studio to generate an interface file, and then it's really very simple to convert that interface file into a console utility. This is basically what the custom code would look like. Once you have your interface, you just basically create a new instance of the client, and then you start calling methods on that client. So as a kind of a cheat sheet here, there's really 3 basic steps that you can do to do this very quickly in a matter of 5 minutes. The first is you use the service util to generate your client proxy. And then all you do is you can open up that client proxy, and if you just paste in this class below all of the interface code, you just add, you don't necessarily have to create a new file for every class. That's certainly the way that you would do it in a real code base, but if you're just trying to hack something together, just tag this code snippet at the bottom of the CS file that the service util generates, and then just add a reference to the system namespace at the very top. So put system using at the top. And what that's going to do is it's going to compile into an exe that you can then use to start directly calling methods on the web service. And the nice thing is it's automatically going to, let's say we're using message encryption here, for example, it's going to automatically negotiate that connection for you and do all the heavy lifting in the background. So you can really just start worrying about fuzzing those methods and not worry about all the other sort of noise that WCF would normally require you to handle. So the long and short of it is that the bindings are a bit of a headache when it comes to talking with the web service, because depending on what you need to do, you're going to have to search for some non-standard tools out there, or perhaps, like I just mentioned, create your own utility. The good news is, though, that there's plenty of room for all the classic attacks. Parameter manipulation, SQL injection, all that stuff is still relevant. It's just a matter of getting the ability to fuzz the inputs is almost going to be the hardest part. And then once you've overcome that, you're going to be in good shape. And I think what we're going to see here is, especially with .NET 4, there's a lot more extensions to WCF that they're implementing. Same thing with Silverlight. With Silverlight 4, there's a much more rich interoperability with WCF that it supports as well. So this is something that we're going to be seeing more and more, and I think it's going to push to the browser a lot more as people start using Silverlight. And right now, Silverlight only supports really a handful of those, the binary bindings. It doesn't support any of the WS security bindings, but that's certainly expected to change down the road. So I think that's something that we'll start seeing more and more of. So we've got about 10 minutes left. I can certainly do any questions if anybody's got any. Yes? The timeout threshold that I defined was anything above 5 seconds. So that's in the code. You can tweak it. I was just doing testing on that box and found that on average they were timing out around 7 seconds. So in my code, I say if it takes longer than 5 seconds, that probably means it's closed. If it's less than 5 seconds, usually if it's open, it comes back in less than a second. So it's configurable, and that's sort of why on the screen I print out the actual response time for each. So what you can really do is, irrespective of whether the tool says closed or open, you can eyeball that response time and figure out whether it's working or not. The question was if I've considered doing other plugins for other proxies. The Fiddler one, again, there's 2 people that have written them for Fiddler, and they're both read-only. So it's my understanding that that's just a limitation of Fiddler. With Burp, I think the one that we've got out there now works pretty well. The only thing I would like to do, which is one of the things that I emailed Portswigger about, was get it so that it can do responses without chaining 2 together. And that's a limitation on his API that he actually said he's going to implement another method to allow transformation after intercept. So he told me he's going to do that probably in the next few weeks or so, and then he's going to email me a beta copy of it to test. So I think my plan is just to maybe improve on the Burp plugin out there, but I think as long as the Burp one works and Burp is free, then anybody can use it. Okay, great. Well, thanks everybody. If you have any questions, come up after.